Hello, so welcome back to another class. Today we will be doing some self exercises based on the things that we had done on the previous days. You can just take a look at the formula above, the formula below in the black box, and the formula below again in the gray box. So we will be using those formulae to solve these exercises. Okay, so let us just start things off so that you don't waste any time. Show that a cross b dot b cross c cross a equal a dot b cross c whole thing square. And a follow-up question is, what can you conclude if a, b, c are coplanar? So how exactly are we going to solve this? Actually, it's very simple. We just start from the left-hand side. So let us see. The left-hand side is a cross b dot b cross c cross c cross a. Over here, what you can notice is this one, it is a vector because it is a cross product. This one is also a vector. This one is also a vector because it is a cross product. Always remember this. If you have to operate, you will have to operate the cross first and then you will operate the dot later. Okay, so we will try to simplify this one first. Okay, so this one can actually be done by using vector triple product. How exactly are we going to do it? Okay, you will see. As you can see over here, we are having four vectors, 1, 2, 3, 4. But if we want to use the formula below, which is the vector triple product, then we will have to use only three vectors over here. How can we do that? If you notice in the formula below again, you can see that the single vector A in the formula below, it is single. Okay, it appears singly. So that is why this one we will convert into just a single vector. We will replace this one with another vector, say p. Okay, so the first thing that we will write. Similarly, it is too cumbersome. Okay, it is okay, you will just be wasting your time if you are not operating this one. So similarly, this one we can replace it maybe with q. Okay, so what we can do is we can write q dot p cross c cross a. Okay, so we can write this one is equal to this, but you have to mention what is q and what is p, where q is equal to this one, a cross p, and p is equal to b cross c. So because again we have to operate the cross first, so we can calculate this one first. Q we will keep it as it is. So what you will be having, I will write it inside a big square bracket. So just use the formula below for this. You will be getting p dot a c minus p dot c a. So this is what we will be having. Q, we can keep it as it is. Now just notice something over here. P, it is b cross c. B cross c dot a. B cross c dot a, just take a look. If we replace p over here with b cross c, so you will be getting b cross c dot a. Again, I repeat, if you are replacing p with b cross c over here, you will be getting b cross c dot a. This one can be easily replaced with the box product, BCA. Right, so over here we will be getting a box product BCA. C, this C comes from over here, minus similarly this one, P, it is B cross C, so we can write it as a box product B, C, BC and C. And this vector, it is outside, which is A. So this is what we are having now. Next, what we can do, it's actually very simple. We can still write Q over here. Do not ever forget to write these dots. Okay, it's very important. This box product, we can interchange the order if you remember. A, B, C. We can write this one as A, B, C. So A, B, C, we can keep it as it is. And over here C. But what is the value of this one? The value of the box product, it is 0. It is 0 because the vector C appears 2 times inside the box. You must remember that if there are 2 of the same vectors inside the box, then the box will be empty. That is, it will be 0. So over here what we can do, this one, okay, will be -0, so we can forget about it. Okay, now what we can do, this one, it is a scalar, because the box product, it is a scalar quantity, so we can take the scalar all the way to the front, ABC. Then we will be getting Q dot C. But just take a look, Q is A cross B. So again, what we can do, if we replace Q with A cross B, over here you will be getting A cross B dot C, which is again the box product ABC. So ABC times ABC will give you ABC whole square. So this is what we will be having. Okay, so this completes the proof, okay, which is I think the question was like this: A dot B cross C whole square, because the box product can be written like this. And also, if you remember, we can even interchange the dot and the cross. Now the follow-up question is, what happens if A, B and C are coplanar? Okay, so we can write it like this: if A, B and C are coplanar, if A, B and C are coplanar, then the box product is 0. So the total value of this one will be equal to 0. So hence the A cross B dot B cross C cross C cross A, it will be equal to 0. I hope that is clear. Okay, so this is what we can conclude. In other words, we can also conclude that this vector, and this vector, they are coplanar, because the box product of this one is equal to 0. Okay, so this completes the first question. Okay, so now let us try to do another question. If you remember, okay, so 3 vectors are coplanar if and only if the box product is 0. Okay, but what if you are given this kind of question show that or maybe are the points, okay, A, okay, we can just make up a few points, B 3 2 1, C 0 1 minus 1, and D 1 minus 1 1. Are these points coplanar? Okay, you must notice one thing over here. We are asking whether they are coplanar or not. The question, it is not about collinear. Okay, if it is collinear, then we will be having 3 points. Okay, 3 points are collinear if the area of the triangle is 0. But take note again, over here we are having 4 points. Sometimes this question is written in this way: R is written in this way, are the points with position vector A bar equal I plus 2j. So instead of 1 2 3, they are writing in this way, but because they are now vectors, so they are asking the question in this way: are the points with position vector plus 3k, B equal 3i plus 2j plus k, C equal j minus k, and D equal I minus j plus k. Are the points coplanar? Okay, are the points with these position vectors are they coplanar or not? So over here, always remember that if you are dealing with coplanarity, of points, okay, you must use the box product. Okay, the box product, if it is 0, then the vectors, they are coplanar. But just take a note over here. So over here, what can we have? Okay, we are having 3 points. Okay, maybe A, B, C, D. Okay, so over here they lie in the same plane. Okay, A, B, C, and D, they lie in the same plane because I can draw it in the plane of the board only. But if these points are coplanar, so what can you say? Even if you form the vectors A, B, A, C, and A, D, we can all draw them in the same plane. Okay, we can draw them in the plane of the board. So A, B, C, and D are coplanar if and only if the vectors A, B, A, C, and A, D are coplanar. A, B, C, D are coplanar. Okay, I am solving it for this one. Similarly, what you can do for this kind of question, you can write A bar, B bar, C bar, and D bar are coplanar if and only if AB, AC, and AD are coplanar. So the 4 points are coplanar if these vectors are coplanar. Okay, so that is AB dot AC cross AD if this vector is equal to 0. Sorry, if this box product is equal to 0. Okay, so now what we can do, similarly over here, okay, what you can do, okay, so over here what can you do is this. Maybe I will just give you in the notes about this one. Okay, I will do it for this because the write-up, it is a bit different, so that's why I will be sending it in the notes, but the idea is the same. Okay, so now let us just calculate AB bar. Okay, now AB bar, it will be B minus A, so 3 minus 1 will be 2i, 2 minus 2 will be 0j, 0j minus 2k. AC, it will be C minus A, 0 minus 1 will give you minus 1, 1 minus 2 again will give you minus 1, minus 1 minus 3 minus 4k. And AD bar, again AD, this and this, 1 minus 1 will give you 0i, minus 1 minus 2 will give you minus 3j, 1 minus 3 will give you minus 2k. Okay, so now that we have calculated this one, now we will just calculate the left hand side of this equation. We will see whether it's equal to 0 or not. Okay, now AB, now this box product, we will calculate it. So that is why I am not writing over here 0. Okay, I want to check whether it's equal to 0 or not. I cannot write it from the very beginning that it is equal to 0. So that's why I will still be writing equal. We will check whether it's equal to 0 or not. This one is a vector, vector, vector. So if you remember the formula for this one, it's given by the determinant 2, 0, minus 2, minus 1, minus 1, minus 4, 0, minus 3, minus 2. So this is what we are having. Now we just have to calculate the determinant. Okay, so the determinant, it's equal to 2. Minus 1 to minus 2 will give you 2. Okay, minus 12, minus 0. Okay, minus 2, 3, minus 0. So over here we are having minus 2 minus 20, okay, minus 6. So the final answer is minus 26. So you can say that it's unequal to 0. Since it's unequal to 0, hence the given points are not coplanar. The given points are not coplanar. So this is a very simple exercise. You just have to remember that if it is a question about coplanarity, you must use the scalar triple product.